Hello, my name is Shravan Sawan and I have been assigned with experiment number 2. So let's begin. So experiment 2 is basically 8086 ALU operations. So starting with the 8086 microprocessor architecture, as you can see this architecture is divided into two parts, BIU and EU. In BIU it consists of segment registers ES, CS, SS, DS and instruction pointer IP. We also have here instruction queue. It is of 6 byte because the maximum size of instruction is 6 byte. Then we have execution unit. All the execution takes place in execution unit. So we have here ALU which performs arithmetic and logical operations. We have a control unit, flags, temporary registers, and also we have some general purpose registers AX, BX, CX and DX. Uh, it, these registers are of 16 bit and we divide it into two parts, 8 bit of 8 bit each, as you can see here, AH, AL, BH, BL, CH, CL, DH, DL, and some pointers SP, BP, like that. So moving forward, about flags. So in total we have 9 active flags, out of which 6 are status flags and 3 are control flags. Okay, so moving towards our main topic, first of all, arithmetic operations. It is performed by all these operations, all these arithmetic and logical operations are performed in the ALU. So starting with the addition operation. So it's very simple. We have already done this in our lab lectures, and sir has beautifully explained it. So covering it in a very short way. So we will first move our first number in AX and move our second number in BX, and we will use add operation. We used to add these two numbers and the result will get stored in the accumulator AX, as you can see here in the example. Similarly, subtraction, we will move both the numbers in AX and BX and we will use SUB is for subtraction, and we will subtract the two numbers. Moving ahead is multiplication. Similar, very much similar. We will move both the numbers in AL and BL, and we use MUL to perform multiplication, and we will store the result in AX. Then division. Okay, for division, what we use is uh, do is first of all we will move both the numbers AX and BL. Okay, then we perform division of BL and we will store the value of quotient in AL and a remainder in BL, or we can also do DX here as given in the example. Then moving forward to the logical operations, also very much similar. We'll just move both the numbers and perform AND operation. AND operation will only work if both the values are 1 and 1, then only the answer will be 1, otherwise all the result will be 0. OR operation, we use OR. In OR operation, uh, both the answer will remain 1 only in all the other cases, just for if both the numbers are 0 0, then only it will be remain 0. Then XOR. Okay, for XOR, it's just opposite of OR. Okay, uh, sorry. In XOR, what happens is that if the answer is 0 0 or 1 1, it will remain 0. In all the both cases, if we have 0 1 and 1 0, it will remain 1 1. Then we have NOT. In NOT, what we do is that if both the answer is 0 0 or 1 1, the result will remain 1 1, and if the input are 0 1 or 1 0, it will remain 0. Okay, so MASM, we already know it converts our assembly code into machine code. Okay, uh, we use MASM as MASM, and then we will do the input the file name .asm. We will save as ASM, or it is the extension for MASM. Then we have linker, which links object files. Okay, so we do this by putting a link file name .obj. Obj is object file extension. Okay. What is debug? Debug is a step by step execution. Uh, what debug does is it will go step by step, check if there are any uh, errors in your file or not, and provide us with what all errors are there. Okay, so we take it as debug file name.exe. Okay, then algorithm and practical implementations. Uh, so what are the algorithm of performing all these operations? So first we will initialize the data segment and stack segment. Okay, then we will load the operand into the register. Third is load the second operand into another register, so that we can use it as a immediate value, because we know that all these segment registers cannot hold immediate value. Okay, then fourth step is that we will perform whatever desired operation is there, and sub or and whatever. Then we'll check the flags if required, such as carry flag or sign flag or any other flags like that. Then we will store the result and exit the program. Okay, so this is what uh, my experiment 2 covers. It was very short, I know, because we have already done with it, so I have concluded it in a very short way. So thank you.